architect. Okay, so he is going to do walkthrough further 1 hour, next 1 hour on this.
So hopes lots of pep talk to all of you. So let's get into the action now. Okay, I'm Manoj Kumar Jain. I'm, as Larry said, I'm the architect and consultant engineer in EMC working on CoprHD project. My session is on giving you a brief overview of what is a CoprHD looks like, architecture of it. When you design anything, first you define what is the architecture, how you want to go about it, and that's what is the architecture we are going to talk about. Agenda is very, very simple. Where it moves.
We encourage you to ask a lot of questions in this session because we're going to set the tone for your understanding of what CoprHD is. So if there are questions, feel free to ask.
My agenda is very, very simple. What is a software defined? So we have said that CoprHD is a software defined storage platform. So I'll just give you a brief overview of what storage defined system is. And today world is a services world, okay, and everything is offered as a service. CoprHD actually offers storage as a service. So I'll just give a brief of it, how CoprHD does it, architecture blueprint and internals. These are the few things which we'll be talking about. So before moving into that space, I just want to know, do you know what type of storage device you use today? Anybody, tell me what type of storage devices are there which you are using? Flash? What is a flash? Which flash you have? What? Yes, you are right. Which flash you have with you? USB stick?
USB stick.
That's a flash. Memory card, that's a flash. Anything else? One. Hard disk. Who said hard disk? And other things?
Solid state.
Solid state. That's another type of flash. Hard disk of which type of memory system? Magnetic. And there is another one which you use daily. Optical. DVD, CD, these are the optical. So there are three ways of devices: optical, second magnetic, and third, the new generation which is coming is a flash. Okay, so storage is everywhere. Everybody needs storage. So how EMC is basically doing this storage use? What is the size of your CD, DVD? Few GB. Okay. Not even one movie comes in that. Okay. Hard disk. What could be the size? 1 terabyte. Maybe some good quality. 2 terabyte, 3 terabyte, 6 terabyte. I have heard is the maximum today. Am I right? How much? Maybe 1,000 movies. Okay. Your USB will not be more than 2. So this is quite limited. Today world, people talk about, what is the highest number you have heard about the size of the data? Terabyte you have heard. What is beyond terabyte? Petabyte. And then? Zettabyte is exajetta. Am I right? Okay. So we talk about today exabyte of the information, which means billions of terabyte devices. Where it comes from? You can't have each hard disk, one hard disk and put things. You need a system which is quite big enough which can absorb your information. What is that system called? Storage. So basically what you will be doing then, if you have to store so much of information, basically you have to know, you are the computer science guys. What you do if you need to store bigger information? You create an array. So same thing what we do, we have a terabytes of the hard disk, we make an array of that, and that system is called storage arrays, and that's what is the enterprise storage means. Enterprise storage means array of storage. Now if I have an array of storage, 1 terabyte, or maybe 1 terabyte is 6 terabyte, 5 terabyte, multiplied by 1000 disk, how much is this? 6000 terabyte will be. Okay, so that's how we grow. And now again there is a limit. There is a limit, I can't make a very big system. I have to further distribute it. They will have several storage arrays, which has to now integrate it. How you will integrate the arrays now? What is the integration technology? If you have several small things, how you integrate the things together? By what technology? Network. Basically, you have to create a network of all the array system to make a bigger system. Okay, and that's how as the information is growing, this network of storage or network of information is also growing. And when the things grow, what happens? Complexity increases. It is complex. Things become very complex. And as complexity increases, and today world is a virtualization world. People, virtualization, what is a virtualization? Anybody? What does a virtualization means? Something which doesn't exist is a virtualization. I doesn't exist, but still I can say, people have virtualization is everywhere today. It doesn't exist, but still it is there. So because of that, now earlier you were managing something which was visible, now you are managing which is not visible, okay, and then your scale, can become very large, and complexity increases. And that's where, industry start thinking of, how to solve this problem. Now complexity has grown very big. It is very difficult to complex, and that's where the software comes as a rescue. Software come as a rescue. Why? Now software said, okay, don't worry about about this complexity. What I can do, I can create an abstraction layer for you, okay, so that you have thousands of now arrays, and thousands of arrays will. I'm just giving the arrays as one example, but when you go inside the arrays, there will be much more things. But I will create thousands of array in an abstracted way, and write a intelligent software in such a way that I can manage it easily. Okay. Earlier, what was the problem? Why this concept didn't fly off? Because first thing, complexity was not there. When there is no need, people don't work. If you don't have a need, you will not work in that area. So as the complexity grows, people find that is becoming difficult to manage. There is an opportunity. Industry work on the opportunity. They see that now there is an opportunity. I have to create something unique to fill that gap. And that's where software defined storage come into picture. Now what I did, because there are thousands of arrays, all are different technologies, they cannot be managed, individually. Sorry, they have to manage individually. And if I have to manage it into the uniform way, I have to create a uniform layer above that. And that uniform layer, if I have to say, is a software defined storage. So when I have to do a uniform way, what is that you have to do? If there are different subsystems which has to uniformly managed, what exactly you will do as a software guys? Something is managed like this, something is managed like this. In Linux, you might be knowing what is a Linux. Okay. In Linux, we have lot of devices. Okay. Each device vendor is different. They do things differently. But in the Linux world, what they have done differently, so that you plug and play. What happens? They have created a layer called driver, device driver. And what that device driver does? What does device? It is abstracted. It is given that these are the APIs you have to implement. How you implement, I don't care. You implement these APIs. And if you implement that APIs, you will become a standard device for me. So irrespective of, you buy a printer from HP or any other vendor, I didn't remember any other name in printer, Epson. Okay, but you just plug it and it start working. USB device, you just plug in, it start working. Different vendors, how they make sure that it will work? Only by that standardization. Okay, so a lot of talk about standardization, and that's where the software defined storage means to it. Okay, any questions on this? Okay, let's move forward. Please feel free to question, okay, so CoprHD as a, at a top level, if I said, it's a, CoprHD is a software defined storage system, okay, a platform I will say, which is extensible with the orchestration engine. So there are, in a software defined world, we have to do two things. First thing is, create an abstraction layer, and then also, because once you abstract it, you have to make sure that the operation which we were doing on the systems earlier, what was the operation? When you do any use a storage system, what you do? Read or write operation. And at the higher level, if we see, you create files, you create movies, store it there. Okay. So basically, it has to create a file system for you so that you can use it. Okay. And this is a some sort of a, it's not, you buy a storage array, plug it in and start working. We want to achieve that stage, but it's not so simple, because once you are in the enterprise grade software, it's little complex to configure it. We want to make it as simple as possible, period. But reality is not so simple, and we want to bridge that gap. How we can bridge it? Do some sort of a automation. Once you buy a hardware, you have seen it. You have to plug in some CD and then install it. It will run some programs. You have to configure it, and then only it will start working. So these are the operations which you have to do manually, right? What we want to do, that we want to automate all those processes as far as possible, so that user just click one button and things done. Your job is use it. So that's what is called service. In the service, you don't go behind that how the things will work. My kid, is now 15 years, but earlier he was 7 years, and he was a good expert in doing all of it. So this configuration steps, whatever is needed, he was doing. So somehow internet was useful. But now for a layman, he was also layman, but maybe. But for a layman, what should be happen? It has to be use only, plug and play. Why the plug and play technology has become very important? Because the intricacies of configurations or uses, is behind that driver software. So you have to just plug and start playing. And that's what is the automation means to us, that we just want to make it as a service. User will say that I want a storage which meets my purpose, which has a high performance, which has a replication as a property, archive will be happening. All these things he will define into some sort of a form. He execute it, everything is done behind it. You know how many products will be used or how many underlying configurations we do? We do more than 20, 30 tasks. Each task is several steps in parallel, and that's what is called the automation. In industry, this word is called orchestration. Orchestration, you know orchestration. Why we call orchestration? What is the word orchestration means? Means it's a synchronized. You have seen that anchor of the orchestrator. He synchronize everything and execute the the tune he is managing. It basically a task of which has to be synchronized, executed, something in parallel, something in sequence, and then summarize them together to do a task. Okay, another thing, so abstraction I have defined. So abstraction, when we do, we have a storage resources, we do abstraction into a world of storage. Two things are important. One is called the arrays. Arrays, we have already seen that. What is our storage arrays? And arrays, second thing is called pools. Pools is basically it's a car of your memory provided to you. So that's called the pool of data. So in CoprHD, we do abstract virtual arrays, which is mapped to some sort of a physical arrays, and then we pools the resources of storage, which is called storage pools. Here we will call it virtual pools. Self-service I have already explained, one-click operation. It's intelligent, repeatable best practice. So this is very important. Once you do the automation or orchestration thing, the repeatability is very, very important. Repeatability means the same operation you execute several times, the result should be same, and that's very important. If you want to provision your resources and it is not repeatable, it fails somewhere, our software is not going to be very useful. When you are working into an enterprise system, the failure of storage is very, very critical. Suppose you are provisioning the storage resources for any financial industry, banking. Okay, for them any failure costs direct revenue loss, and it's not even it's not accepted in that world. So our software has to be very much robust. Whenever we do any work into that, do a thorough testing, do all sorts of negative testing also possible, so that it's repeatable. Flexible means, we are from the EMC, and we are not just one vendor who does produce storage arrays. Do you know who are the other vendors apart from the EMC who are into the storage world? Hitachi, this is a new word, and HP. Okay, yeah, yes, IBM, Hitachi, HP, and there are a lot of new players are coming which do not exist 5 years back. If you look at the new world of the storage arrays, those are some different type of technologies which are even somewhere EMC is also catching up with them. There are a lot of new names has come. Okay, these all Hitachi, HP, IBM, EMC, these are the veteran into the storage industry. But third party storage and there are a lot of new vendors are coming, and that's where we have to be flexible enough that we support. If we are a software defined storage, we have to support all the storage arrays. EMC, it may be a baby of EMC, but because now we are the open source, we want to be sure enough that that our technology get integrated with any other array in the world, and that should be the thing. So that's why we want to be very flexible enough, and we have to create interfaces in such a way that all the we talk about abstraction, all physical resources, which irrespective of where it comes from, should get integrated into our system. And last point is we are open. That's why you guys are here. Okay, any questions on this slide? Guys, please be interactive, ask questions. I like questions.
What about the
Best practices is a good question. So we are in the storage industry for almost I don't know 15 years I am here, so more than that. So we have built that expertise, intelligence, that when we do provision the storage resources, what all things we have to do, which basically customer, our experience says this is the best. if you provision resources in such a way, this is the best. Means giving you an example that storage has a different flavor, which is called, one is called, we call it tiering, storage tiering. If your data is not used for a longer period of time, so means that you occasionally use it, you will not like it to put that data into the high performance storage. Okay, and if your data is you use it daily, it's very critical for your applications, you will use it into the best storage. So what is the best storage? Flash. What is the best storage? Flash. So but flash is very costly. Okay, if the enterprise start using all arrays into the flash, it will be a costly proposition. So each arrays has a only limited set of flash memory available to that. So your workload, we talk about all these things as a work. In the storage world, the term workload is important to understand. It's something, the job which you are executing and type of job which you are executing called workload. So we will put that workload into that tier, flash memory. And have you seen that, you might have seen that, all your records, banking records, if you say, everybody say that, after 6 months, the records will not be available to you. So maybe some guys are good, they will say 1 year. And if you want to get those records, they charge you extra money. Why do they do it? You can say, but everything is stored in your system. So generally what they do, they archive those records into such a memory which is very cheap. What is the cheapest memory? Magnetic disk. And magnetic disk, a SATA disk, which is very low performance, is we use, and we put all our data into the SATA disk. From where its extraction is, first thing it is archived, recorded, extract is a problem, and also it is slower. But you are not in hurry. If you are looking for information 1 year back, definitely you may be having some need, but it may not be so urgent to achieve it. So slow process, do it. So that's what is we call the best practices. That we can provision your resources, finding what is the best thing to do. Good questions. I like it. Yes.
Using any kind of learning algorithms to, find out what the best practices are?
We will love to do it, and we are doing something, but we will love to do more of it, and happy to work with you guys. If you have some vague idea what could be done, please suggest, and